All right, so continuing on with this concept of the breakdown of polygons, we're going to use this chart a lot in answering the next few questions. When we're working these problems that we're fixing to do, we are going to be trying to read a statement and tell whether it is true or false. And when you read a statement, and let's just talk about this chart. When you read this chart from the bottom to the top, you can use the word is. Like a square is a rectangle. All squares are rectangles because by definition, a rectangle is a parallelogram with four right angles. And that also is what a square is. So all squares are also rectangles. A rectangle is a parallelogram. Because all rectangles are parallelograms. Parallelogram by definition is a quadrilateral with two pairs of parallel sides, which all rectangles have. Notice on all of these, we're reading from the bottom up. A square is a rectangle. A rectangle is a parallelogram. A rectangle is an isosceles trapezoid. And so if you are reading from the bottom to the top, you can use the word is. Now, if we're reading from the top to the bottom, which is the next little section here, you would use the phrase can be. A rhombus can be a square. A kite can be a rhombus. It's not a guarantee, but it can be because not all kites are rhombuses, even though all rhombuses are kites. Not all rectangles are squares, even though all squares are rectangles. So it's when you're using this chart, if you're going from the bottom to the top, you would use the word is. If you're going from the top to the bottom, you would use the phrase can be. So a rectangle can be a square, but not always. A parallelogram can be a rhombus, but not always, because not all parallelograms have four congruent sides. They can, but it's not a guarantee. So what we're going to do is we're going to read these following statements. And if I had you in my classroom, I would put you into pairs and have you do this by yourself with your partner, and then we would talk about these out loud. And I would probably give each pair of students, one of these to talk about and explain to the class. But I like these kinds of questions because it really goes into some higher order thinking. So the first one that we're going to categorize as either being true or false is A, an equilateral triangle is isosceles. An equilateral triangle is isosceles, and notice we're going from the bottom to the top, so we can use that word is, and I want you to think about this. By definition, isosceles means at least two sides congruent. Well, all equilaterals do have at least two sides congruent, so all equilateral triangles are also isosceles, and so that's why this one would be true. Part B, a square is a regular quadrilateral. And if you'll remember, we've already covered that definition of regular. Regular means four congruent sides and four congruent angles because a square has four sides. So regular means equilateral and equiangular. And squares do have four congruent sides and they have four right angles. So it is a regular quadrilateral. That would be true. On C, if one angle of a rhombus is a right angle, then all angles of a rhombus are right angles. And this one, might kind of confuse you, but rhombus means four sides congruent. If one of the angles is right, that would have to make all of the angles right, because with those four sides being the same, if one of those angles is right, then automatically that becomes a square. So it's a rhombus with a right angle, which means four right angles. And so that actually becomes a square. So this would also be true. If one angle of a rhombus is a right angle, then all of the angles of that rhombus have to be a right angle, and then it becomes a square. A square is a rhombus with a right angle, and we kind of just talked about that. Rhombus means four sides the same. Square adds in the right angle. If there's one right angle, then that would make all of the angles right angles, and so this would also be true. all of the angles of a rectangle are right angles, and that's by definition. If you go back up in your notes, by definition, a rectangle is a parallelogram with 4 right angles, and so all angles on a rectangle are right angles. That's also true. We got a lot of true statements going on. A rectangle is an isosceles trapezoid, and notice you're working from the bottom to the top, so it is. All rectangles are isosceles trapezoids because trapezoid is at least one pair of parallel sides, which a rectangle has. Isosceles is when we have those 2 congruent sides, which all rectangles will have. So all rectangles can also be named isosceles trapezoids. Some isosceles trapezoids are kites. And so if you'll notice here, there is no connection at all between a kite and isosceles trapezoid because kites do not have that pair of parallel sides, whereas trapezoid does have that pair, at least one pair of parallel sides. So there are not going to be any isosceles trapezoids that are kites. That's going to be false. If a kite has a right angle, then it must be a square. If a kite has a right angle, then it must be a square. And I'm going to actually see if I can find you guys an image of this. Give me just a second. Okay, so this is somewhat of a good visual, but we have this one right angle in a kite, and you can see that that definitely does not guarantee that it is a square. And so a kite that has a right angle is not necessarily a square, so that is going to be a false statement. An isosceles trapezoid can be a rectangle, excuse me. So an isosceles trapezoid can be a rectangle if it has 4 right angles. And so because we're going from top down, the word can be is important there, and that is a true statement. A trapezoid is a parallelogram. So a trapezoid is a parallelogram. It's not a guarantee because trapezoids have to have at least one pair of parallel bases, where parallelograms have to have two pairs of parallel sides. And so it can be, but you cannot use the word is there. So that is going to be false. No rectangle is a rhombus. Well, that's definitely a false statement, because if you have a square, that is a rectangle and a rhombus. And so a rectangle can be a rhombus if it's a square, because a square is like a rectangle and a rhombus had a baby. And a square is a kite. And if you go back up here, you can see that all squares can also be named kites, because by definition, a kite is a quadrilateral with those adjacent sides congruent, and a square does have that. It does have those adjacent sides that are congruent, so that is true. And these statements can kind of throw people for a loop. That's why I said it's a good thing to maybe do in partners, really talk them out. Try to maybe go online. You can give the students freedom to go online and do some research of their own, to use this hierarchy chart of polygons to answer these kinds of questions. Okay, a couple of more problems for this lesson to finish it up. And what we're going to do on number 5 on A and B is we're going to solve for the value of x, knowing that a quadrilateral has 4 angles that add up to 360 degrees. Okay, so what we know here on part A is that we have a 90-degree angle plus a 115-degree angle plus another 90-degree angle plus x. That has to sum up to 360 degrees because the 4 angles on any quadrilateral sum up to 360. We'll combine like terms by adding 190, 115, and another 90. That's going to add up to 295 plus x is equal to 360. We'll then subtract 295 from both sides. And you're welcome to use a calculator. Then we'll take 360, taking away 295, and that tells me that x is equal to 65 degrees. This angle here is 65 degrees. Now on the next one, this appears to be a parallelogram, and we'll talk about some properties of angles of parallelograms in the next unit. But for now, I just want you to use the fact that the four angles of a quadrilateral add up to 360 degrees. So we know that 112 plus 68 plus another 68 plus x is equal to 360. And just like the last problem, we're going to add 112, 68, and 68, which is 248 when we combine like terms here, plus x is equal to 360. Subtract 248 from both sides. And so we're going to have 360 minus 248, and that's going to give me that the value of x is 112 degrees. And that is true based on what we're going to learn about the angles of a parallelogram in our next unit. You see that those opposite angles are congruent to each other. Okay, the last thing that we're going to do is we're going to do some just drawings on dot paper. You can also, let me go back online, and you can print a page of dot paper. I mean, you can just go in and download a PDF of dot paper and print this for yourself or for your students. But I'm going to show you something else you can do rather than dot paper that can be really fun for your students. So if you have room in your budget to use geoboards, these can be used in place of dot paper. There are also digital versions of geoboards that you can go on and find online. So let's see if we can just find one of those. Maybe an interactive geoboard. And I know they're out there. Give me just a second to find one. And let's actually just search one real quick. So interactive geoboard. So let's see how this one works. And this is something, you know, when you're a teacher, you're just going to have to kind of play around with. So here, you know, this is where you would place your rubber bands. So you can have these in your classroom with a rubber band. You can print out dot paper, or you can use an interactive geoboard. But what we're going to do for 2A is we're going to draw on our dot paper or on an interactive geoboard. We're going to draw a scalene triangle. So this is what's going to help students really reinforce those definitions. So definition of a scalene triangle is a triangle with three sides that are different. So we're going to draw a triangle where all three sides are a different measure. And here's a very quick version of that. All three sides of this triangle are different lengths, and that's what a scalene triangle is by definition. The next thing that you have on here is to draw a square. And so 6B, we're going to draw a square either on dot paper or on an interactive geoboard. You could draw one very small, just like this, because a square is a quadrilateral with 4 right angles and 4 congruent sides. Or you could do, you know, a bigger version of that. So here, 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 here. So just kind of give students freedom and let them go with it. A trapezoid, by definition, is a quadrilateral with at least one pair of parallel bases. So let me go here, and then I need a parallel base, and then I can connect these two bases, and I have a trapezoid. And I see here my parallel bases. There's a lot of different ways you could draw a trapezoid though. So we could go here. We could even make a trapezoid that's an isosceles trapezoid, but that would still be a trapezoid as long as we have that one pair, at least one pair of parallel bases. Okay, on D of your notes, we are going to do a convex hexagon. So remember, hexagon by definition is a 6-sided polygon. And then convex, if you need to go back and look up the definition of convex, it's a simple closed curve in which in which a segment connecting 2 points is wholly contained in the interior. And so let's see what we can do here. I'm going to have 1, 2, 3, 4, 5, 6. So my hexagon here has 6 sides, 1, 2, 3, 4, 5, 6, and any two sides that like if I go to connect, and I'll do this with red, if I go to connect any 2 points that are on the exterior, you'll see that these segments are wholly contained within here. Now I could come back and draw another hexagon, 1, 2, 3, 4, 5. Okay, so now you see how I made this dip in here? If I came in now to connect these 2 points, I have a segment that's on the exterior. So this green one would be convex, while as this red one here would be concave. All right, next thing that we want to do, let me go look back at the notes. We want a concave quadrilateral, so 4 sides, but we need that side that caves in. So let's do orange. 1, 2, 3, 4. So we have a 4-sided polygon, a quadrilateral, but it is concave because if I came in here to connect these 2 points, this segment's on the exterior, and that happens because of this dip in, this cave in right here. Okay, last thing we need is a parallelogram. So parallelogram, by definition, is you're going to have those 2 pairs of parallel sides. And so there's a lot of different ways you could do this. All squares, all rectangles are parallelograms. Most of your students are going to just kind of play it safe with what a typical parallelogram looks like, but they could also draw a square or a rectangle. Because, you know, by definition, all of those are going to be, and let's just go back and look at your notes. So if I say to draw a parallelogram, they could draw a rhombus, a square, or a rectangle. All of those would be parallelograms because all of those would have those 2 pairs of parallel sides. So quadrilateral, in which each pair of opposite sides is parallel. So rectangle, a rhombus, and a square all have those. So if you ask students to do that on a geoboard or dot paper, any of those would work. So we went over a lot in this lesson. And, you know, if you were teaching this in public school or even in private school, and you were trying to follow the standards, you know, all of this information would span out over different grade levels, over weeks or even months. And so it's a lot that we took in. And I wish that we had more time, you know, to go more in depth into all of this, but it is assumed to be knowledge that you already have that we're just refreshing on. But I promise you, if you actually get to teach a lot of this material, there's so many fun and engaging activities that you can do to cover these definitions, categorize the triangles, the quadrilaterals, work with a lot of these different shapes. And so teaching geometry can really be a lot of fun for the students as well as the teacher.